Good morning. Today we're going to talk about Module 6, the data link layer, in your course Introduction to Networks. And just a few things we will cover. We'll talk about the purpose and function of the data link layer, look at some of the media access control methods on both a LAN, a WAN, and wireless. And then we'll look at the functions of the data link frame. Some of this you've seen before, but we need to take this chapter separately. Sometimes that helps. Again, this can be used by you personally, or you can use this in your classroom, whatever works for you. So the purpose of the data link layer is it sort of keeps track between communication between two endpoints. So up at the top right, the web server there, and the person working at their computer. And basically, it only takes place at that NIC, at that card in your computer. And what it does, it frames all the data that comes down from the upper layers. Also performs error detection and takes care of those corrupt frames. And I like to put it in plain English. The data link layer defines how data is formatted for transmission, which we'll look at different formats. The data link layer figures out how much data can actually flow between those nodes, how long that flow is, and what to do if something goes wrong. So you might just kind of put a asterisk by those things. It is most concerned with detecting those errors. It can't correct those errors. So keep that in mind. It can detect errors, but not necessarily correct errors. There are two sublayers to that data link layer. There is the logical link control, and then there's the media access control. And what that means is that logical link communicates directly with the network layer. So there is a intervening layer, you might say, between the communication with the physical, because up here you've got the network layer, down here you've got the physical, be that any kind of media that's connected. The MAC layer is talking to the physical layer, which in turn talks to the logical link, and the logical link communicates with the network layer. And there's different things that we'll look at here in a few minutes. We'll look at a little bit of these different MAC sublayers. Remember that MAC sublayer, that's where the MAC address is on the NIC. That's that manufactured stamped MAC address, physical address. And then the logical link is going to frame all of that, the address, and make sure that we're using the correct addressing. And there's the flow control. At each hop along the path, a router performs 4 basic layer 2 functions. So let's look at this with a scenario. Move this out of the way. And we're just going to take this top scenario here, where we have 3 routers, and we're talking about the router performing those basic layer 2 functions. So we think about often a router performs layer 3 functions because that's where the IP address is. But a router also participates in layer 2 functions because a router has a NIC. So basically it has a MAC address. So we're just going to do bring up the simulation mode here. Make this a little bigger so we can see everything. And we're just going to use ICMP as our event list. And we're just going to ping, I believe this is 10.0.0.1, yes. So I'm going to take this router, come down here, make it a little bigger, make it a little smaller. And we're going to ping 10.0.0.1, which is the address here of this gig port on router 0. And we're going to go ahead and get a few things in there to look at, and then we'll stop it and look at some of those packets. We'll get some success first. Okay, it looks like we've got some success, so let's just stop it right now. So if we notice the ping begins at router 2, and it's building that ICMP packet. And if we look at here, we've got the in layer, here with the out layer. So the router is building this packet, destination 10.0.0.1. The source is 11.0.0.2 on this router. This is an Ethernet 2 frame. So we're going from MAC address to MAC address. So it passes it down to the layer 2 frame, and then it passes it down to the physical port. And on the next one, we see that router 1 here in the middle, it receives it on the physical port. It passes it up to the layer 2 data link. Notice this is still an Ethernet data link protocol. Passes it up to the third layer, and then on the outgoing layer, we get the source IP and destination IP. And it's going to ARP here because we didn't, I should have started it later on because there's not going to be an address there because it's ARPing. Let's go down a ways here to this one. So we're going to go layer 1, layer 2, we're de-encapsulating or decapsulating, it's said both ways. Then it goes from layer 3 to layer 2 to layer 1. So it's very simple. Notice we're looking at here this Ethernet layer with routers. So if we look back at our PowerPoint, we can see it does accept a frame. It de-encapsulates it up, then it re-encapsulates it down into a new frame, and it forwards it out. And we saw that right here on this one. I've got it messed up here. Go here and here. There we go. So it accepts the frame from media. It de-encapsulates the frame to look at the packet on layer 2 and layer 3. Then it re-encapsulates it. It takes that IP address, re-encapsulates it into a frame. So here's where the framing takes place. And then it forwards that new frame to the next network segment. Okay, so that's 3 routers. I'm going to go back to real time, and we're going to look at some different kinds of packets. I believe you've seen something like this before, but we're going to look at it again. Up here, we saw these routers only using layer 2, but they use the layer 3 for the IP addressing. Here we have a switch, and we're only going to see layer 2 frames. So I'm going to start a ping from this guy. Let me go ahead and ping first to get that ARP table full. Over here to 10.0.0.1. So let's get that ARP table built so we don't have all the pausing on our simulation. Okay, so now we should have an ARP table, and we do. So we should be okay now when we start the simulation. So let's start the simulation to look at those layer 2 only frames. And we're just going to do that ping again. We're going to start it on its way, and I just want to basically look at the switch. Okay, we're going to stop it. Let's go all the way back to the switch. Okay, let's stop it. So here we go from PC 0 to switch 1. We see we're on switch 1. We're the ACT device S1. We're looking at the OSI model. Switch receives the frame on its fast Ethernet. It de-encapsulates it up to layer 2. There's an Ethernet again, and it doesn't go up to layer 3. That's for the router. So the switch is not going to go up to layer 3. It'll just basically start passing it over back to layer 2 outbound, because now we have the source MAC address and the destination MAC address. That's the router MAC, well, that's this router MAC address, and it sends it out. And if we keep going up, of course, to the router, we see the router now incorporates that layer 3. So just so you know, the router does have, you have to have the layer 2 on the OSI model, but the switch only goes up to layer 2. It does not ever get to layer 3. That's for the router. Okay, so let's shut that one down. And let's go down and look at something a little bit different. So far, all of these are connected via Ethernet. So that's that Ethernet 2 protocol in the data link. Well, let's connect I'm going to have to put a module into this one. I'm going to connect serially. So I have to turn the router off, and I'm going to put in a serial module, turn it back on. It's going to reboot, but I save the configuration. So if you do this, you'll want to make sure to save the configuration. And while that's rebooting, I'm going to go ahead and add another router down here. We'll call this router 4. And I've got to do the same thing with it. Turn it off. I'm going to add a serial module in there. Turn it back on. And let me connect them now. I'm going to connect them with a serial link. Whoops, wrong thing. So I'm going to put that on the router. Whoops. Try it again. Serial 010. I added that module in, so I now have a serial link. And then I'm going to serial 010. All my configuration was wiped out of that router, but I had the forethought to save it. So I'm just going to copy back that configuration. Don't want to save it. Okay, so I've got that back. And then I have to do a little bit of configuring over here, the new interface that I added. Interface S010, IP address, I'm making that the 9 network, 9.0.0.2, 255.0.0.0. No shutdown, and I think I forgot to bring this one up. I did. Okay, so I should have green arrows now. And I do have to add some routing into this particular one. And I'm just going to use the simplest protocol and add that network in. So we get some routing going on. I just want to make sure that my new router, go ahead and name it so I don't get mixed up. RT4. I'm just going to make sure it has an entry and it does not have an entry yet. It may take a while for it to populate. Let's see if I need to add that network in here. Okay. 11 and 12. Let me check this one. So that's 10 and 11. That's correct. Let me check this one. Okay, there we go. Now I've got the 11 and 12. It took a while to populate. So let me ping first to make sure that I can go all the way from this desktop all the way over to this router. So I'm going to ping 9.0.0.2. It says it's unreachable. Interesting. I like it when these things happen because we can troubleshoot. So it's telling you it's unreachable from 12, and this is my 12 router. So 12 should have that network in there. Let's see if it does. Show IP route. It doesn't have the 9 in there. Let's see if this one has the 9 in there. Show IP route. No 9. So this one must be the culprit. Show run, and let's make sure that I put the 9 network in there. I have the 9 network in there. Okay. Make sure I've got the interface correctly configured. I don't have it configured. Right. Interface S010, IP address 9.0.0.1, 255.0.0.0. No. Shut. Just see if I can ping the corresponding interface. Okay, I got that. Surely it wasn't just that simple. Show IP interface brief. To look at the interfaces, I've got 9001. Let's see now if this PC can ping all the way over there. And it did. Okay. Now we can look at what I want to look at after we did some troubleshooting. Good exercise in troubleshooting with your students. If you have them do this, have them look to see why it's not going. Look at each router and see what's happening. So I'm going to go into the simulation mode. Our purpose is to look at frames. So let's do that. So I'm going to ping again to get some stuff in there. Start the simulation and let it run a little bit. Shouldn't have to ARP since we already pinged once. I'm going to let that go back and then I'll stop it. Okay. So if I go from router 3 to router 2 and I look at that OSI, we see we're Ethernet 2 here. If I go up a layer, if I go out a layer, we're right over here at router 1, even though ignore this because I clicked this one. So now I want you to notice the difference. Now layer 2 changes. It's no longer Ethernet 2 because it has a serial connector with it, which is an HDLC, high density link. So it's a high density link. Now notice that it is an HDLC frame, and it even uses the word frame. So I wanted you to see that not all layer 2 is Ethernet. There are different protocols. It depends on the connection. So that's why layer 2, whatever kind of frame is being passed through the data link layer, it depends on the connection. This connection is a gig or an Ethernet, so it's going to be Ethernet 2. This connection, however, is a serial cable, which is a high density link. So layer 2 is going to sense that connection and it's going to be HDLC. And if we go to the next one over here to router 4. We see again that it comes up when it receives it from this router right here. It says, oh, okay, I'm connected via HDLC frame, goes up to layer 3. When it sends it back up to this router, it's still an HDLC frame. But when this router here sends out something back to router 2, you guessed it, it would be an Ethernet 2 frame. So the data link is dependent on the physical layer, or layer 1. Whatever's connected, that's the kind of frame that gets sent out. Okay, so let's do one more scenario, and let's look at wireless. So here we have a wireless connection. Already set it up, should be all configured. So I'm going to ping from this wireless PC all the way over to this 10001. I've got everything set right. We should be able to ping right through with no problem. Should work. That's the famous words of every tech person. And it did, so I don't have to worry about ARPing. I'm going to do it one more time to make sure my table's correct. Okay. Now let's look at the simulation and look at that frame. Right now, we're not physically connected. However, the media is wireless. So you should know, and your students should be able to figure out that this is not going to be HDLC or Ethernet. It's going to be something else. So let's look at that ping while we're in simulation mode. And let's get a few frames in there so we can see what's going on. And that's enough, really. So I'm going to start at the wireless PC. There's my wireless PC. And since it's a ping, it's going to start at layer 3. But now layer 2, it sees what's connected to me. Oh, wireless. So layer 2 is wireless. And the port is going to the wireless port on my little router here. And if I go to the next one down, we see that on we're now at the wireless device. So it receives it on the wireless port. It's still wireless layer 2. And now look what changes. It's going to send it out on an Ethernet data link protocol because that's what's connected to the other side. So again, layer 2 is depending on whatever layer 1 is connected to its port. And remember, back on the serial, I actually had to put a module in there that be able to use a serial. So that's how layer 2 can change. There are other layer 2 protocols that take place. We just looked at 3. We looked at Ethernet, we looked at HDLC, and we looked at wireless. So let's close all these out here and close this out and go back to our scenario here. Save our work. So as far as topologies go, I believe this is familiar territory for you. You have a physical topology, and of course in Packet Tracer, one of the very first things you did was you learned in Packet Tracer what that physical topology looks like. In the classroom, you can see your routers and your switches and your cabling. That shows the physical connections. The logical is like the virtual connections, which is like IP addressing. We did a point-to-point a few minutes ago in our scenario where we had a serial cable connected, and this called a point-to-point. And so this is point-to-point WAN protocols. They're very simple. We won't really talk about those much in this course. These are some other topologies that are used. There's a bus topology, and notice you call it bus because it's just one connection all the way through from beginning to end, and everything's just sort of connected along the way. Half and full duplex. Most switches default to full duplex in troubleshooting, sometimes you'll have a switch that's set as half duplex, and you have to have both agreement. They either both, if you're connected between switches on port 1 to switch port 1 on another one, switch 1 and 2, they both have to be the same duplex. You can't have one half duplex and one full duplex. They either both have to be half or both have to be full. This is fairly important. You might think about a carrier sense multiple access with collision avoidance. That's wireless. So wireless is not going to send out a frame until they make sure there's room on the media, on the wireless connection. So that is collision avoidance. So they don't want to have a collision. They're avoiding a collision. Ethernet, a bus topology, let's go back to that bus topology. They're sharing that media. They're sharing that medium. So with Ethernet, they're going to detect to see if there's a frame on that bus yet. If there's one on, then they move back and say, well, I'll send it later because there's not room now, and I can only send one at a time. And there's some other ones as well. So there's that carrier sense multiple access collision detection, and that's that half duplex mode. And the reason that it is collision detection, if it's half duplex, you can only send one way and receive one way. With full duplex, you can send and receive on the same wire, and you're using more wires in that Ethernet cable. So that's why collision CSMACD, you can't, if both sides are trying to send a signal, there will be a collision. So that device, that PC, will say, wait a minute, there's a collision. I'm just going to have to wait to send mine. Collision avoidance, that's used with wireless LANs, half duplex, and so forth. Again, there's a little bit of information on the frame. So here we have the packet in the middle. That contains the data, whether it's your email. It's also got the IP address, some other things. But this is the header and trailer of the data link frame. So remember, data link, you got to remember the word frame. The OSI network is, you're talking about packets. So there's a frame start and stop. So here's the start of the frame. There's the frame stop. If we looked at these in bits, you would see certain bits that designate the frame start and certain bits that designate the frame ending. The source and destination, that's the MAC address. So that's all in this particular one addressing. You have the source and the destination. I'm sorry for my clock going off. So that's where the addressing. The type is the layer 3 protocol. So what kind of type is it? And then you have the control, the flow control services. If you see the word flow, you should immediately think, oh, that's the data link layer, sublayer. That's where the flow is in. And then you have, after the data's through, is detecting that error. Now remember, data link can only detect errors. It cannot fix those errors. So data link is about detecting errors. And we already looked at Ethernet, wireless, point-to-point. We used a point-to-point connection, but it was HDLC. This is a layer 2 protocol that the CCNA does not include anymore. It used to. This as well is one that we used to study all of these in CCNA, but the only ones really in CCNA are Ethernet, wireless, and some of this HDLC. And again, what is on layer 2 is because of what is on layer 1. Thank you for your attendance.